erase somebody left a little circle butt up here for some reason. Everybody say goodbye. Poor little circle butt. As you guys come in, can you try to long divide that? Give it a try. If you got it, it's okay. It's part of the reason I want to talk about this first. Ronnie, welcome. If you would please, sir, as soon as you're settled, try to long divide this by hand. Yeah, that should work. Oh, it should be -1. Okay. That's what I did. That's better. Does it go further? No. Gotcha. I think I can change it real quick. Ooh, it's close. Okay. How far am I? Oh, okay, okay. All right. Yeah, okay. I changed that just a little bit. All right, so preparation for the future. I'm going to change this a little bit. All right, guys. Has anyone successfully long divided that? You think so? You think so? Hold on. Let me catch up to you guys. What'd you get for an answer? Huh? 610? 610? Okay. Hey. Are you going? Oh yeah, that's okay. Alright, so if you're just getting here, you missed out on a huge amount of fun. So what's interesting is, okay, so level 1, it's been forever since we long divided, right? In fact, you might be sitting there saying, I was told there would be no long division anymore, Jeff. Well, too bad. We're trying to get in the direction, I want to be able to do this, which means you want to be able to do this. So I want to be able to long divide this. And then we are desperately going to want a shortcut, and I will show you a shortcut eventually. The shortcut only works sometimes. That's why I still haven't known how to long divide. The funny thing is, if you do enough of these, you'll start to realize that you don't think about 71, you think about 7 into 43. 7 times what is close to 43? 6. But when you multiply, 6 times 7 is 42, 6 times 1 is 6, yes? So very often what we do is we'll think about the first pieces. We'll write a number down based on the first pieces, but then whatever number is, it's got to multiply by both parts, of course, right? I'm making a big deal out of this because it's going to feed right into how that guy works. Okay. What's the next step? Good, change the sign. 7, and then I bring down the 1. 71 goes into 71. 1 time, multiply, change the sign, add, bring down 0. Okay. So what does that mean? What did we just figure out? 71 times equals. What did we just figure out? 71 times what equals what? 71 times 610 is... So long division, when it goes in evenly, is a method to factor a big ass number. Yes? So where you got it? Okay. And really quickly, would you say that I factored it completely? Is there another factor of this? What goes into 610? Obviously.
10 and 61.
Do it again.
10 and 61.
Oh, sure, yeah. 10 and 61, and then I can keep going here, right?
Yeah.
I believe 61's prime. Is everybody with me? So once you get something to work, doesn't mean you're done factoring it completely. No. So if you look at the problem I wrote up here, and for those of you at home, let me write it down here. Is everybody semi-cool with this? You guys remember this? And I know what's really trippy is if, for some people that were born, like I had a student from Russia, that's the first thing that comes to mind, but in other countries too, they do not do division this way. They set it up kind of like sideways to how we do it, which is trippy as shit. So if that's true for anybody, you have to let me know, because I'm gonna set up the division for this the same way that we do here. I could potentially try to figure out how to do it for you. What did I write over there? Minus 5x plus 6. Now real quick. We've done problems like this before. There was a problem like this on the last test. And some of us were confused about it. But real quick, before we think about this guy, what would I do here? How could I do that? Factor. How's the top factor? How do I factor the top? What two numbers multiply 8? Add to be negative 6. 2 and 4. And then what can cancel? So my answer is x minus 2. Yes? So I have a number here, I have a number here, and I have a number here, and when I have a fraction, I cancel the common factors. So x minus 4 is a common factor. Kick ass. So it would be great if I could factor this, correct? If I could factor this, I can then see if x minus 1 and see if I can kill it. Can anyone see, what would you try to use here to factor this? You would try grouping. Can you guys see, or do you need to start it? That grouping will get you nowhere. What comes out of these two? X squared. X minus 2 is left. What comes out of these two? Negative 1. 5x minus 6 is left. Can I go further if those two parts are not the same? Even though some of us do, we can't. Legally, we can't. Let me stop for a minute. I really want you guys with me. So normally, if I have a problem like this, the first level is, can I factor something so I can kill stuff? Yes? Looking at this problem, I want it to be the same. It feels like it should be the same. 4 terms, let me try to group. Does grouping work? No. But I tell you this, that top will factor. We just don't know how to do it yet. So if you thought you were done learning how to factor, you weren't. Right? We can only go up to 4 terms. And even then, here's a 4-term dude that does not work. but it will factor. So, let's do this. I'm going to keep this guy kind of showing a bit, and I'm going to set up this problem like a long division problem. So let's see. Jeff, two things. Put your glasses on, and then remind yourself what the problem is. There it is. You write this down first. All right. How excited are you guys? Are you guys sitting there thinking, what have I done? Did I do something to somebody in a past life? What have I done? So we're about to long divide polynomials. I desperately hope somebody here goes, okay, it's not as bad as I thought it would be. We'll see what you guys think. That looks horrendous. Do you guys agree? Okay, I understand. I agree. It looks kind of gross. Personally, I could see it, but it also looks amazingly neat to me. So real quick, why did we put a 6 here? Because 7 times 6 was close to 43, yes? You guys with me? Okay. X, I'm going to look at the first piece. X times what is x cubed? X times what is x cubed? X squared. So x squared times x is x cubed. X squared times negative 1 is?
Negative x.
All right. Is everybody with me so far? We did exactly the same shit up here. 7 times 6 is 42, which is close to 43. So 6 times 7 is 42. 6 times 1. And now I'm at the level where I do what?
Subtract.
Change the sign. That's right.
Yeah.
So if I change the signs, do you see that? I change the sign. I'm going to subtract, which means each thing has a sign change, yes? Every step we're taking is exactly the same step that we do with numbers. Exactly the same. It just looks different. So what do I get? What's x cubed minus x cubed?
0.
Good. And what's negative 2x squared plus x squared?
X, negative x.
If I owe you $2, then they give you $1.
Negative 2.
Negative x squared, yes? Then I
Give down the x cubed.
bring down the minus 5x. Every step is the same. Every step is the same. Did I tell you that every step is the same? X times what is negative x squared?
Negative x.
Negative x. So negative x times x is negative x squared. Negative x times negative 1 is plus x. Is that cool?
Yes.
And then I
Change the sign.
change the signs. X squared minus, negative x squared plus x squared cancels. Those always have to cancel. If they don't, you did something wrong. Negative 5x minus x,
Negative 6x.
negative 6x. Bring down to 6, yes?
Yes.
How you guys doing? Can you guys tell me, is this better than you thought it might be? I mean, I need you to notice, we keep doing the same thing over and over. So the minute you get it one time, you got it. X times what is this, that, multiply, change the signs. X times what is this, that, multiply, change the signs. Blah, 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 blah. So x times what is negative 6x? Negative 6, yes? Negative 6 times x, incredibly enough, is what we said it would be. What's negative 6 times negative 1? And then I change the signs. What happens? What's 6 minus 6? 0. So, can anyone tell me what the hell we just did? Did we, sort of like when I divided 43,310 by 71, we got an answer which meant we factored 43,310, yes? Can you say something similar here? What did we factor and what does it factor as? What did we factor? We factored this. What does it factor as?
X minus 1 plus.
Yes, x minus 1 times x squared minus x minus 6. You guys with me? If I do 8 into 88,
That's 18180. So 88 is 8 times 11. 88 is 8 times 11. So we got it to go in evenly. So this is this times this. Did we just factor this?
Yeah.
The thing that before today we had no way to factor. You guys, I understand on one level why you might be underwhelmed by what just happened, but we just unlocked the freaking door as to how to factor this. Now, real quick, can anyone go further? Am I done factoring? Can this go further maybe? Now this guy can't go further. There's only one x. I can't break that up. This guy is trinomials, x squared. What numbers work? Careful. 2 and 3. So it'll be, which one's negative? 3. So what could we do now? We could say, what's the multiplicity of each? What's the intercepts? I could get the y-intercept, everything we did before, yes? The problems we were working on yesterday and last week were already factored. And then I can see the multiplicities, I can see the intercepts. So of course the next level is, what if I give you some shit that ain't factored yet? So there are going to be problems where you can just straight up factor it like we did before. Cubes, squares, trinomials, grouping. But you're going to hit a lot of these where none of that old stuff works. You're going to have to use division. Okay, how are we doing so far? So can you guys, what do you guys think I have to be careful? Let me see, what do I want to do to you? Let's see. What about, yeah, I'll do this. This could come out gross, but too bad for everybody. If this does not come out gross, I'll be amazed.
Did you need to put an X by the other?
Nope. Oh, I did. Yes. Sorry. Thank you, Christy. You put an X that there. Otherwise, you just put those numbers together. So one thing is, I made the bottom a little worse, but the steps don't change. The steps cannot change. There is one thing about the top that is a problem. Does anyone see anything about the top that's different?
No.
We don't have X cubed.
Cubed. We don't have x cubed. If I have a number, all right, everybody stay with me, right? I have a number. There's 2 thousands, 5 tens, and 3 ones. What number is that? 2 thousands, 5 tens, 3 ones. What number is that? 2051. What did you put? Because we're missing 100s. I didn't have any hundreds. Yes. What'd you put? Freaking 0 in that place. Yes. So, since variables are numbers and they have to act like numbers, I probably want the same kind of placeholders we have for numbers. When I'm missing 100, there's no hundreds in my number. I'm going to have a 0 in the hundreds place. There's no x cubes in my number. So when I set this up, no, Jeff. Okay, that works. Maybe. Okay. X to the 4th plus.
2x.
Nope. No x cubes plus 2x squared minus 11x plus 5. And now let's see why. Let's really see why. So one level is the same shit we do in numbers. When I'm missing tens or hundreds or thousands or whatever, we just put a 0 in that place. So it's exactly the same thing. And let's, if I start this off, you'll immediately see why this is useful. How do I start this off? There's a lot of shit here, yes? So one level of math is not easy. And I think I was lucky. I kind of do this naturally. I don't look at all of it. All I care about is this guy and this guy. When I look at this, that's all I see. Because that's the first thing that matters to me. I can let go of everything else. And not all of us are able to do that. I think a lot of students have the whole thing in your head. And oh my God, that would drive me insane. All I give a shit about is this guy and this guy. X squared times what is x to the 4th? X squared. So then x squared times x squared is what we said it would be. X squared times x is, and see why it's nice I put this here? Because now I have a place for that to go, yes? Poor little dude. X squared times negative 1, bless you. X squared times negative 1 is
Negative.
negative x squared. And then I
Change signs.
change the signs. Now, real quick, that is the most common mistake when students do this is you forget to change the signs, things go crazy. Okay. Are you guys at all with me? And again, if you think about it, when we say subtract, we literally mean change the sign and then add. That's what subtraction is. So that's exactly what I'm doing. When I log divide, I subtract this, which means change the signs. These cancel like they're supposed to. What do I get here?
Negative.
Negative x cubed, and what do I get here?
Plus 3x.
3x squared. Good. And then I bring him down. Now, I mean, I've been talking a lot, which has made this longer than it really should be. I'm not going to give you like x to the 10th power. Do you see what I mean? That just gets dumb. That's just busy work. So I'm not going to give you some huge degree and you have to turn your paper over and you have to tape more paper over so you can hold the whole damn problem. That's dumb. The most I would probably give you on a test or something is x to the 4th, because that's long enough. Yes? What do I do now? I forgot. Yeah, all I care about now are this guy and this guy. So x squared times what is negative x cubed? Negative x, I like it. So negative x times x squared is what we said it would be. Negative x times x is negative x squared. Negative x times negative 1 is negative x times negative 1 is negative x times negative 1. Two negatives make
X.
positive when you multiply, so that's plus x. And then I change the signs. Okay. Does anyone see? There's a lot of writing, but we keep repeating the algorithm. We keep repeating the same exact steps. So that's why I'm not going to make a big ass problem. It's just like, do it again, do it again, do it again. Okay. So if I put these together, what's 3x squared plus x squared? 4x squared. Negative 11x minus x? Nope. Yeah, my debt grew. I wish I could put two debts together and make them go away. I've tried, and the bank said no, and I was like, damn it. I was like, I have a master's degree, man. They're like, I don't care, you're doing it wrong. Damn it. All right, what do I do now? How do I know when I'm done? Isn't that a good question? I know I'm done when the degree of what's down here is less than this guy. Because can I do x squared times something to become him? X squared times what is this guy?
4. Just 4.
4. 4 times x squared is, that's insane. 4 times x is 4x. 4 times negative 1 is negative 4. Good. So then I do what? Change the signs. These cancel. Negative 12x minus 4x is? Negative 12x minus 4x. Negative 16x. 5 plus 4. 9. Now, how the shit? How do I know I'm done? First question. How do I know I'm done? Because I can't do anymore. I'm tired. No. How do I know I'm done? What's the degree of this?
Less than.
It's less than the degree of that. So I can't multiply this by some whole x thing to make it become this, because this is less than that. Less degree. So I know I'm done. How do I write this? Do I put big ass R like I'm in second grade? No. So how do I write remainders? So let's do a real quick example. Here, everybody like this. 7 into 79. How does that work? 7 times what is 7? Let's just jump to the chase. 11, yes? 77. How do I write this? How do I write the remainder correctly? You guys remember? Does anyone remember? No, we don't do big ass R. That's second grade shit.
Smaller.
$11 and 2 sevens, yes. So look. Real quick word about this. If I put 79 over 7, just go with me for a second. Let me explain mixed numbers to you better. You ready? What do I wish was on the top? What number is below this that I wish I had put here? What number is just right below this that I wish I had put there instead? That would make this so easy. 77, yes? What is 79? It's 77 plus. Is everybody cool with me? Just if I rewrite this like this, there's nothing wrong with that. Hell, I can rewrite the top as 70 plus 9 and just don't do shit for me. Well, what does this do for me? Math boy? Well, what's 77 divided by 7? 11. What's 2 divided by 7? I don't know. Now, what is missing? This is one of the dumbest decisions in all of mathematics is right here. Because does this mean 11 times 2 sevens? Obviously not. That would be 22 sevens, which is just a little more than 3. This is a little more than 11. So what operation is understood to be here? Addition. We just decided, I think we were drunk that day. Right? We'd gone out the night before. Like, let's work on this problem. This sounds good. It's this horrible. But there's an understood plus sign, yes? So, does anyone know how to write that correctly? I get a start. You could do it. What did we do with this? What was the leftover? 2. Well, how do we write it? Plus 2 over 7, yes? How do I write this? Plus over? Okay, good. I need you to see how there's a lot of writing, but not a lot of intense work. There's a lot of writing, I agree. You look at that, that's mammoth. Look at that thing. If I made a few more terms, that's where you might have to turn the paper over, yes? And I've done that. I've taped paper together, rolled it up, and turned it in like a scroll from my teacher. Roll it out on your floor so you can follow my, I've done that shit, because I had to. We're not going to have to do that, don't worry. I'm not going to make them too big. But if you really think about it, the level of math we did was not intense. In fact, we kept doing the same thing over and over. A lot of writing, our brain looks at it and goes, holy shit, we just did a lot. We actually didn't do that much. Now, did we factor this? Let me ask this a different way. Why did we not just factor this? Because did it go in evenly? Did this go in evenly? What does it mean to go in evenly? The remainder would be,
0.
was our remainder 0? No, so we didn't factor it. But we did long divide it, so what the hell? That's pretty good. So, does anyone have like calculus 2 potentially in your future? All right. For you guys especially, but for the rest of you, this semester we're going to do more with this. But in Calc 2, you do actually use this. A decent little amount. Yeah. Okay. So here's the motivation, and then I want to show us a shortcut. If I gave you, let's kind of review what we did yesterday very quickly. If I gave you this, can anyone tell me anything about the graph of this? Anything, I'm open to it.
It's going to be cubic.
Why?
Because the highest thing is
7. Good. Does everybody see that? If I were to multiply this out, the highest power would be 7. And the shortcut is, what power's on this guy? 1.
You just add all the power. 2 plus 1 plus 4 is 7. So this would go like x to the 7, so the end behavior would be cubish. All right, somebody else tell me anything else. That's pretty good.
End behavior, we know what it does at the ends.
Yeah, x-intercepts are
Good. Yes?
Go for it, I'm sorry.
3, 0,
3, 0,
negative 1, 0,
negative 1, 0,
and 1, 0.
1, 0. Now, somebody else, tell me anything you can about each of those x-intercepts.
Tell me anything. What do we know about 3, 0? Tell me something about the intercept 3, 0, what the graph looks like at that point. Yeah. Yes. So 3, 0 bounce.
What's it going to do at negative 1, 0? Somebody else. Why is it going to bounce here, by the way?
even multiple.
Yeah, the multiplicity is 2, yes? So it's going to act like a parabola there. It's going to bounce either down or up depending on where it is on one side.
What about negative 1, 0? Somebody else? What's it going to do at negative 1, 0? We can do. What's the multiplicity?
Multiplicity is 1. So
Is 1. It's going to go through like a line.
Hit gas. So it's going to go through. Because multiplicity is 1. And finally, what about 1, 0? Good? Good? Yeah, good. Because what's the multiplicity? 4. So even multiplicity, and all multiplicity, it's kind of a silly word because
We already have the word degree. The degree of the factor that that number came from tells me how it's going to act around that number. If it's an even degree, that's parabola. It's going to bounce either up or down depending on where it is. If it's an odd degree, it's going to go through. Okay, I like it. So this is what we did yesterday, and I think a little bit last week. I can't remember. You guys kind of with me? But before today, everything we worked with was already factored, yes? I think yesterday we did a couple out of the book that we factored, but it was easy to factor. You guys kind of with me? Oh yeah, I could look back at the one problem that wasn't easy to factor. That's true. Okay. If I can find that thing somewhere. So, the next really good question would be, okay, if I give you something that is not currently factored, like this, let me see if I can make one that'll work. Oh boy, this is always exciting. Give me a moment. All right. Oh, okay, that works. So then I just need, shoot, I don't want it to act like that. That's too bad, Jeff. Oh, make it like this. There we go. So then it'll be. Okay. No. Very exciting. It's actually not bad. Okay, I like that. Let me double check. Good. Well, sorry. Trying to make problems that work on the fly is neat. All right. So I give you this, and I want you to find the intercepts. I want you to tell me, does it bounce or go through, blah, 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 right? And of course, the thing that sucks about this is not factored. And then what sucks even more is the only way we knew how to try to factor doesn't work. Do you guys see grouping will not work? You can see that? Because if I take x squared out, that's x minus 3, and that's not x minus 3. So I'm dead in the water there, right? Maybe. So again, I'm trying to make motivation for you to buy into this division problem, because long division and the shortcut I'm going to show you especially are factoring tools. We're able to factor more.
And right now, you guys don't really understand. Maybe you do. Factoring is the name of the game in a lot of mathematics. I don't care how high in math you go, at some point a problem is going to involve factoring. That's just the way it is. It just happens. So the more tools I have to factor something, the more math I could do. The more math I could do, the more science I could do. The more science I could do, the better everything is. Okay. Unless you're a mad scientist, then stop. But now the question is, I really want you to understand. Sorry. This one we got to factor, correct? You with me? But where the shit did I get this from? I'd have to know this in order to divide by it so I can factor it. Are you guys understanding? So if I give you this, you're like, what do I divide by to make this factor? I'm not going to tell you because I'm an asshole. And because part of what I'm trying to teach you is how do you determine what to even try. So really kind of with what's happening. So we were able to factor that early one because I told you to divide by x minus 1. I gave you the thing that would work. In general, you're not going to have that. You have to figure out, what do I even try that might work? So I'm going to build in that direction. We're going to come back to this. So everybody keep track of this. We're going to come back to this guy. So let me ask you this. If I had this, and if I were to multiply it out, dear God, don't. But if I were, and you guys know the first question, you know the answer to the first question I'm going to ask you. What would the highest power in x be? This is the whole idea of end behavior, yes? What would the first term be? X to the fourth. Because you would get two of them here, right? And then foiling, you would get another one here, and then that would get another one there. So you get x to the fourth, yes? Now, let's turn our attention to the end. What number, I'm going to have shit. What number is going to be at the end? What constant would have to be here? Believe it or not, you know this. What number would have to be there? Where would it come from? Like, if it was only this, what number's at the end? If it was only that first piece isn't there, what number's at the end? You can do it. Yeah? Negative 20. You guys see that? All right, well, what number do I pick up? What number now? Yeah, so it'll be negative 20. What's negative 2 squared? 4. So it'll be 4 times 5 times negative 4. 80. So if I have, I really want you guys with me. This number, whatever it is in general, has to come from the product of those, yes? And if I write x minus 2 twice, it might be easier to see. So then it's this times this times this times this. How did we get x to the fourth? This times this times this times this. Okay, how do I get to the end thing? Well, the n times the n times the n times the end. Is everybody kind of with me? So if I have a problem, don't care what it is. If I have this here, no, Jeff. Screw you, Jeff. Okay. There you go. Look at you go now. Can't be stopped. You could be stopped, actually. All right, what if I have this here? Okay. Just talking about whole number stuff. Could x plus 7 be a factor of this? Could x plus 7 be a factor of this?
Yeah.
Why? Because 7 goes into 28. Yes? So if I break this up, if I actually factor this thing, one of them could be x plus 7. Because then the other ones could be x minus 2, x plus 2, x minus 1, and then they all come out to be 28. Could x plus 6 be a factor of this? Is 6 a factor of 28? Is 6 a factor of 28? Can you multiply 6 by something and make it 28? 6 by a whole number, I should say.
No.
Okay. Let me be better. What about x plus 11? Could that be a factor of this? Hell no, 11 doesn't go into 28. So what could be a factor of this? X plus or minus 7. Keep going. X plus or minus 2. So what should I do to make this easier? Shouldn't I just take and write all the factors of 28?
Yeah.
Okay. I really want you guys with me. So what are all the factors of 28?
2, 4,
Don't forget about 1,
1,
2, 4,
7,
7.
4.
So now I'm doing this, yes? 14, 28. Good. I put plus or minus in front because it could be positive or negative. Are you guys with me? Okay, I like it. So then, now, I want you to realize, I'm going to say 2 things in a row. I would then say, all right, let me try to divide this by x plus 1. If that doesn't work, let me try x minus 1. If that doesn't work, let me try x plus 2. If that doesn't work, let me try x minus 2. If that doesn't work, let me try x plus 4. You understand what I'm saying? Now, does everybody understand that? Let me immediately follow up with, I'm going to teach you some shortcuts. I'm going to teach you how to shrink this list. The longer that list is, and the less lucky you are, you could imagine having a list 12 long, plus or minus a 24 long, and if you don't choose right, you're on a test going, that didn't work, that is end of the test. Okay, so I have to give you clues or give you a way. I'm going to give you several ways to make the list shorter. But I really want to go straight. Does everybody understand our process here? What's the motivation? If I can factor this, I can find the x-intercepts, I can talk about multiplicity, I can do all the shit we did before. It's just that stuff was already factored, which is way too nice. They ain't doing that in the real world. If I'm able to factor, I can do. Okay, so now it's all about how do I factor this? Oh, long division is a way to factor if I can't factor like normal, and there ain't no way I'm going to factor this with a method we talked about before. So long division. Okay, so what do I long divide by? Oh, I look at the last number, I get factors of it. Right? And then you make your list, you're like, I decided I don't want to do this because that's too much, and I don't blame you. Okay. Is everybody with me at least on the mechanics of this? And understand, I will, if you really understand, you do not want to try all those because you can just be unlucky and finally get the answer at the end. And I'm not going to do that to somebody. Too bad. No, I'm not like that. But I really want everybody understanding. If it's factored, I can see a lot of shit. If it ain't factored, I can't see shit. The only thing I can see is what is the y-intercept of this? 28. 0, 28, yes? That's the only thing that's good when it's not factored. I can see that. Okay, so let me do this. I'm going to show you the shortcut. I'm going to give you a handout, which is amazing. I never do that. And then I want you to work on the handout. Yeah, perfect. I want to double check what I had on that thing. Well, let's do this. Let's develop the shortcut. It only works in very specific instances, which is why it is so beautiful. And we'll see if you guys agree with that adjective. So what I want to do first, I want to do a little tiny long division, just a little tiny one. And then I'm going to show you the shortcut next to this. So you can see all the steps showing up, just a lot less work. Little tiny, look at that little tiny dude. So I'm going to do this a little bit. Well, let's see, you guys help me out. What goes here? Good, x times x is x squared plus 2x, change the signs, these cancel, negative 4x minus 2x is negative 6x, bring down the 3, what goes here? How long can you do it? We'll find out.
6. -6.
Yeah, -6. -6 times x is what we said it would be. -6 times 2. And then I change the signs, so then I get a remainder of 15, and up here I put 15 over x plus 2. Okay, how's everybody doing? Very quick side note about the remainder. When we did 7 into 79, we got 11 remainder 2, right? Look at me writing it with a big R. Remainder 2, so 2 sevens. The remainder tells me how far away this was from being something that goes in evenly. So this is 2 more than something that goes in evenly. This remainder tells me this was 15 more. If I took 15 away and made this minus 12, that would have went into it evenly. So even if the remainder is not 0, it actually tells me good information. This is 15 away from that going in evenly. Do you have to understand everything I just said about the remainder? No, it's just really good to know what the hell the remainder means. Now, here's the idea of the shortcut. What are the dumbest things we do over here? All right, here's a dumb thing. Look how not important this shit is. What is this always going to do?
0.
These are always going to cancel, so why would I keep writing the dumb things, yes? You guys with me? Do you notice it's the numbers that are most important? Why is this a 1 here? Why is there a 1 coefficient here? Because there's a 1 here, yes? What if there was a 2 here?
2.
There would have been a 2 here, correct? Okay, everybody keep that in mind. Whatever number is in the problem is the number that's in the answer at the beginning, yes? As long as I'm dividing by 1x, okay. Isn't it dumb then to keep writing all the x's? If I would have just said the coefficients are 1, -6, and 15, that's the most important information to know, just the numbers. And then I could put it back together. Also, what was the easiest mistake to make when doing long division? Do you guys remember? Forgetting to do what?
Change the sign.
Forgetting to change the sign. So wouldn't it be great, if we're going to make a shortcut, wouldn't it be great if we just change the sign right at the beginning? So I don't have to change it every damn time. I just change it once. Do you guys agree? Because if I have a long division, at some point I could forget to change the signs and the whole thing goes to shit. So if I could just change it once and be done with it, just never have to think about it again, doesn't that sound good? Some of you guys, hopefully, I don't want to be forcing you to say yes. It's okay if you're like, no, it sounds good, man, just show me what it looks like. Okay. Some of you guys look like I was forcing you. Yes, okay. So instead of writing x's, I'm not going to write any x's. I'm just going to write numbers. So but instead of writing a 2, I'm going to do like we just said. I'm going to change the sign of 2. So I'm not going to write the variables because they're dumb. They just take time to write. I just want the numbers. I just want the coefficients, and I can write the answer. So I'm not going to write any x's, and like we said, I'm not going to put a +2. I'm going to change the sign now. So I don't have to change the sign every damn time. Okay, maybe. So we put this little guy, just because it's the format of it, we put him in a little, what I call a penalty box. I don't watch much hockey, but I just like the idea he's in the penalty box. Can somebody tell me the coefficients of the problem here? What's the coefficients of the original thing?
1, -1.
Yeah, 1, -4, 3. Okay, this looks much cleaner already. And the great thing with this method, it doesn't grow like this way. It doesn't. It just grows this way. So if I had more terms inside, it would just kind of keep going sideways. So why was there a 1 here? Because there's a 1 here, yes? So whatever number is here just comes straight down. This bottom row is going to be the answers, the coefficients of the answer. So I should get a 1, a -6, and a 15. Or else we can throw all this out and we can leave. Whenever I say that, I'm like, watch me make a mistake now. Right. Now watch this. This is so cool. Okay. Didn't I multiply this by 2 to get the 2 here, and then I changed the sign, but I already changed the sign? So here's the thing. Bring the 1 down. Multiply. What's negative 2 times 1? Negative 2. Add. What's negative 4 minus 2? Now notice. Right there. Didn't we just do that? Negative 4 minus 2 is negative. Didn't we just do it? Doesn't it look a lot cleaner? What do I do now? Negative 2 times negative 6 is? Negative 2 times negative 6 is? Positive 12. 3 plus 12 is? 15. So the only drawback, I don't know if you guys are really with me or not, we took out all the variables, we just focused on the coefficients, we changed the sign at the beginning instead of every time, and we did the same work. It just is so much, look how much cleaner that is. The trade-off is you have to know how to interpret the answer. What was the degree of the original problem? And we divided by x to the first. So the answer should be 1 degree less than what it started off as, yes? So it was x squared, so now the answer should be 1x minus 6, and then this is the remainder term. All right, let's do another example. How you guys feeling? Has anyone ever seen this before? Out of curiosity? Yes? Anybody else feel like you've never seen it before? Sounds like, how do you feel? We've only seen one. How many have we seen? One. So if it doesn't make 100% sense, it's okay. It's really cool though. I mean, I desperately want, does anyone think it's so cool that negative 4 minus 2 is negative 6? There it is. Negative 4 minus 2 is negative 6. There it is. 3 plus 12 is 15. 3 plus 12 is 15. It's just cleaner. I don't know how else to say it. The trade-off with synthetic division is it only works this is called synthetic division, by the way. This here is called synthetic division, which I think is a really dumb name. It just makes it sound more complicated. Makes me think about like oil or tennis rackets getting synthetic stream from like tennis rackets. Synthetic division only works directly if the bottom or the divisor is x plus or minus a number. So this was x plus 2, it works. If it's x minus 7, it works. If it's x squared plus 3, it don't work. If it's x squared plus x minus 1, like the last one we did, it don't work. If it's x plus 7, yay! You guys got it? If it's 2x plus 5, it does not work directly, but there's something we can do to make it work. We'll worry about that in a bit. Let's not focus on that for right now. Okay, so what I want you guys to do, can everybody please take this problem here. I don't know, Jeff. Sure, okay. And I want you to, no, let's just, it doesn't matter, Jeff. It's probably gonna come up gross. Too bad for everybody. Go ahead and do synthetic division to this. Let me put the example problem up here again. Oh. So do that problem. Can't show everything. Using synthetic division. Damn it. Do you guys got the problem right now? Okay, my arm is there for emotional support. crazy. So if you ever watch me doing a problem like this in my head, you'll see me doing this. I'm doing synthetic division, right? This way, that way, this way, that way, this way, that way. So how do I set this up? Who goes in the penalty box? Sorry? Positive 3, good. So we don't write the variable, and we change the sign at the beginning instead of each time. We don't write variables, so what numbers go up here?
1, -4, 5, positive.
And what 2 things do you have to be careful about before you just write the coefficients? What's good about this? Am I missing anybody? Nope, I got third, second, first, none. Yes? I'm not missing anybody. Also, is it in order? So if I switch these, I better switch them back before I write these down, or else it's going to come out no good. This is built on the assumption that I have decreasing degree. That's why it works. Okay. Now what gets me started here?
Bring down the 1.
Bring down to 1.
1 times
3 times 1, 3. What do I do with those?
34.
Yeah, add them, multiply,
2.
add them, multiply, add. Yes. That kicks so much ass. That kicks so much ass. I mean, imagine what this would have looked like if you did long division to it. My God, so much unnecessary writing. Can anyone tell me what the hell that answer means? Yeah, we had a cubic. We divided by an x thing. So how many x's should I have left? 1 x. You can do it. I had x cubed. I divided by x. So what should I have left now? X squared. I lose in x because I'm dividing by x stuff. So I lose in x. And then keep going. Minus x. Keep going. Plus, no, we already had the x term. Squared, first power, constant. It just goes down in degree, yes?
Then 10 over x.
Yes, and then 10 over x minus 3. Well, this was a third, second, first, constant. This goes down by a degree, so this is second, first, constant, remainder. So the only real tricky part, if you haven't memorized multiply, add, the only tricky part you have to be careful about is interpreting what you get at the end. Maybe. So did this go in evenly? No. And what tells you that?
Remainder.
Yeah, this wasn't 0. Good.
So you're saying that because that you could subtract from the original.
Yeah, if this was if this was a -6, if this was 10 lower, this would have went in evenly.
Yeah.
Yes, that's one thing the remainder tells me. It actually tells me one more thing. Do you guys, all right, listen. Even if you don't 100% at the moment remember the steps, was that hard, what we just did? The level of mathematics involved is multiplying and adding. That kicks ass, yes? So we took a division problem, I need you to understand, we took a division problem and turned it into a multiplication and add problem. That kicks so much ass, yes? So here's the next level neat thing. Can you guys please take this polynomial? Can somebody, let me write it over here. Can somebody take this polynomial and shove a 3 into it? You see what I mean? Just plug a 3 in. Maybe get a calculator or something to help, or maybe not. It's up to you. Throw a 3 in there. All right, anybody get that?
10.
Yeah, you should get 10. So it'd be 27 minus, you can do it, Jeff. 36 plus 15 plus 4. That'll be negative 9 plus 15 plus 4 is 6 plus 4 is 10. And 10, of course, was the remainder. So here's what's really cool. If you synthetically divide a polynomial by a number, the remainder is what you would get if you plug that number in. You guys would. And very often, synthetic division is actually quicker than plugging a 3 in and cube it and build them. I saw how many of you guys reach for your calculator. I didn't need a calculator to do this, did I? The level of stuff here is very low. That's kind of cool. Okay, maybe. Yes, sir.
So theoretically, if you were to make the first x in the column the fourth power instead of the third power, would the 10 not be a remainder anymore? And would it then be?
Oh,
x?
well, because what would have happened if I just make this a fourth power, there would have been a 0 here for cube. This would have all been off a bit, so this number almost definitely would have been different,
Yeah.
right? Okay. In fact, it would have been 91. Yeah, in case you're curious. But yeah, it would change. That's all we have. Yeah, it would totally change. Yeah. Okay, maybe. How we all doing? I'm throwing a lot at you. All right, I'm gonna finally shut the hell up. Here is a thing I want you to work on. I'm going to start by yourself, and then I'm going to try to have you guys help each other out. Oh, by the way, on this side is an example long division and an example synthetic, a couple of them. So you can have this next to you if you're doing these problems. I think, Christina, rearranged these from what I showed you. So tomorrow, we're going to do the, I don't know if you remember, on the other side, I had a different thing about that. So let's do it tomorrow. Just to make sure everybody's starting off with the right step, what do you have to be careful about with this problem?
There's no x.
There's no excuse. You gotta do something to help you out with that. There's 0 x cubes. Okay. All right, guys, let's take a look here. I'm just a poor Southern math boy. Okay. So, okay. Now, what did I make a mistake on? Yeah. Good job, Jeff. Oh man, I'm gonna need more room. Okay, let me try this again. So x squared plus x minus 1, x to the 4th. I got no x cubes. There we go. All right, that's called being too locked in. So then, how'd you guys go? What'd you put here? X squared. So then x squared times x squared, x to the 4th. X squared times x. And again, real quick, when I multiply, I just pick up that many more x's, right? I had 2, I pick up 2 more. I had 2, I pick up 1 more. And then x squared times negative 1, of course, is just negative x squared. And then I
Change signs. I subtract this whole thing, which means I would distribute a negative, so I just change that into change all the signs. These cancel like they're supposed to. This gives me negative x cubed, and this gives me, good, negative 2x squared, and I bring down the x. X squared times what is negative x cubed? Yes, negative x. So negative x times x is negative x squared, negative x times negative 1. And then I change signs. Those die like they're supposed to. 2 minus, negative 2 plus 1 is negative x squared. X minus x, 0. And then I bring down the 5. X squared times what is negative x squared? So then I get negative x squared minus x plus 1. Change the signs. So I end up with x plus 4. And how do I write the remainder? Plus x plus 4? Yeah, all this business. Okay.
How we doing? Now, I was thinking about doing this, but let me see. If you want me to show you, I can. If you make x a number, if you let x be 3, do you all agree I would get a fraction here? You guys with me? If I let x be 3, wouldn't I get a fraction? Sorry. If I let x be 3, the top would be a number, the bottom would be a number. I get a fraction, yes? Okay. In fact, you guys see how the top would be a larger number because there's a 4th power on the top here. So it would be top heavy. What can I do with a top heavy fraction? I can make it into a mixed number, yes? And if I put a 3 into the answer, this will be a whole number, yes? This piece will be a whole number. 3 would be 9 minus 3 is 6 minus 1 is 5. This will be the fractional piece, so it would be a mixed number. So this is the equivalent of changing an infinite number of fractions into mixed numbers. That's what we just did. Because what fraction could this be? Any x value I am allowed to put in there. Just can't let the bottom become 0, right? That's crazy. Okay. Then we went to synthetic division. Who goes in the penalty box? 1. Now, there was a good question about what this meant down here. The way I would say this is I'm about to synthetically divide by 1. That's how I say this. I'm about to divide synthetically by 1, which means I was dividing by x minus 1. Yes? Okay, maybe. So then, how do I get this thing started?
Bring down the 2.
Yeah, bring down the 2. 1 times 2 is 2, that's crazy. Negative 3. 1 times negative 3 is negative 3. Negative 6, so what's the answer?
2x.
Good?
X minus 3. Remainder is
Chicken Z acid. And just to point this out, this was down 6 from this going in evenly, yes? You guys with me? If I made this go up by 6, this would have went in evenly. Okay, just to point that out again. The remainder, what the remainder means. What do I have to be careful with this one? You don't have a x squared term in there. So who goes in the penalty box? Negative 3. And then I got 4x cubes,
0.
0x squares,
11.
11x's, and a constant. Okay, and then, repetition is good. Once you see it, it's basically this, you get started and then you just keep doing the same thing over and over. So this gets you started, multiply, add, multiply, add. Boy, this is getting crazy. Multiply, what do you get? I think it's 141, is that right?
Yeah.
Add. Now that's the remainder. Can anybody else tell me interesting about this? Anything interesting? Anything? Anything? If I plug a -3 into the top, I would get a -140 out. That's what we talked about earlier. The book calls that the remainder theorem. So if I plugged in -3 into the top, I would get a -140 as an output. But for most of the time, all this is going to mean is you're not a 0, you suck. Zeros are the best things in the world. So what do we get as an answer? 4x to the what power?
Squared.
Squared. I like it.
Negative 12x
plus 47.
And then minus
140 over x plus 2.
kabam. Kabam. I really want you to think about it. Remember the first long division problem we did, and compare it to this guy. This is so much more streamlined. Okay. Now, I don't blame you if number 3 was a little weird by instructions.
Just B.
Huh?
I just didn't do B.
Part B? Okay, we'll get there. So now you understand better what this means. What am I going to put in the penalty box? 2. So what am I actually effectively dividing by as a factor, as a thing? X minus 2. So let's see, on top goes the coefficients. Bring down the 1, I'll do this a little quickly. Add, multiply, add, multiply, add, multiply, add. So what just happened?
No remainder.
There's no remainder now. What we're going to be doing is we're going to give, I'm going to give you this, and I'm going to say, find the x-intercepts, determine the multiplicity, determine the behavior, find the end behavior, blah, 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 yes? Can't do much of any of that. We can tell the end behavior. Can anyone tell me the end behavior of this thing? Can you do it in the air? What's the end behavior of this polynomial? What's happening? The first number you flashed me is not correct. You got to be careful. These are subtracting and adding. So what's the highest power? 4th. So you got lucky. It would look like this, yes? I want somebody to do this and go, I don't know. And I'm like, you're right. Holy shit. Is everybody with me? So you can see the end behavior. You can see the y-intercept. That's nice. But you can't see a damn other thing. Is everybody with me? So I'm going to give you this problem, and I'm going to say, give me the x-intercepts. You're going to be like, well, shit. And you start dividing. Now, why did 2 make sense? Because 2 is a factor of 20. Yes? Okay. I like it. I like it. Now watch this. I could just, now real quick, can somebody tell me what this represents? X to the third minus 6x squared plus 3x plus 10, right?
Yeah.
Well, I'm just going to do this. I'm just going to stack my cakes. I'm just going to keep going. I'm going to divide by 2 again. Because if I wrote x third minus 6x squared plus 3x plus 10, I would just put their coefficients down. Oh, so why would I've already got them down. They're already there. Let me just keep going. Bring down the 1. Multiply, add, multiply, add, multiply, add. So what do we get? Each one of these is what? Each one of these represents what? As a factor. X minus 2, and I've got how many of them? 2. And what were we left with here? Be careful. This was x to the 4th. So this is x cubed. So this is, every time I synthetically divide, I lose an x because I'm divided by x something. Yes? So x to the 4th, x cubed. What's this? X squared. Minus 4x minus 5. Is that factored all the way? Can you factor this more? Yes, that was a factor. 2 numbers that multiply to be -5, add to be -4.
X minus 5.
Yes. Yes. So now I could ask you all the questions. What's the x-intercepts? What's the multiplicities? Does it go through or bounce? What's the y-intercept? Graph the damn thing. Go crazy. Maybe.
You factor x minus 2.
What do you mean factor? It's already a factor. Don't multiply it out, that's bad. Yeah, don't do that. That's bad, okay? The whole name of the game is factor it, so then I can see what's going on. Okay. Yes?
How do we know to divide it twice? Like, how do we know when to stop?
Every time I get something to go in, it relates to a factor. So in this case, x minus 1 was not a factor, x plus 3 is not a factor. I got 2 to work. That means there's one factor of x minus 2. I got 2 to work again. That means there's another factor of x minus 2. And then I was left with stuff that had their own factors. So if I got 2 to go in 3 times, what would I put over here? X minus 2. If I got 2 to work 3 times, what would I put here? X minus 2 to the third. Each time it works, it tells me another factor. Okay, maybe. So real quick, what if I won't even show you. I did something and I got 1 to work, it worked. And I got 4 to work, it worked. And I got 1 to work again, and then I got 5 to work. -5. Can anyone tell me what all that shit means? Yes, that's a known. That's not a new thing. What does this come from? Keep going, x minus 1. X minus 4. I got another x minus 1. See? I got another x minus 1. Yes, so now I got x minus 1 squared. And then I've got x plus 5. So I don't need you. I had to repeat. Is everybody with me? I think I see that. That's the connection. So when I synthetically divide by a number, if it goes in evenly, that means x minus that number is a factor. That kicks so much ass. Because synthetic division is quick. You can quickly get answers. Thankfully, you can also quickly tell it doesn't work. Yes? Because if we want to factor stuff, I want to be able to tell, is the remainder going to be 0? And sometimes you can kind of think ahead and go, that's a dead end. Let me try a different number, right? Maybe? Screw you, Jeff. Okay. What was the last thing I wanted to talk about? Just to kind of get us thinking ahead. Here is the next level of this. Oh, here. You guys remind me, by the way. If I had, get out of there. If I had this. What numbers would I try to synthetically divide by?
All factors of 50.
Yeah, so what are they?
1, 5, 3.
Sure, if you want to do it. We got and 15. Good. So never forget, 1 goes with somebody, that goes with somebody. What if? Here, tell me this. What if I had one that was already factored, but it looked like this? Can anyone tell me the zeros of this thing? Give me any 0 you see. What makes this 0? 1. What makes this 0?
A fraction. 3 or 2.
Sure, so you can make it equal to 0 and solve. Subtract 3 divided by 2, so what do you get? Subtract 3 divided by 2, do you see that? So can you do this in your head? You would subtract 1, divide by 3, you would get, yeah. The numbers that are on the bottom came from the numbers that are where in the result? The factored form. Where do those numbers come from on the bottom? Where did the 2 come from? Why is there a 2 here? Where was it? It was at the beginning, yes? Where'd that 3 come from? It was at the beginning, yes? You guys with me? Okay, maybe. The numbers at the end tell me the tops. The numbers at the beginning tells me the bottoms. Because is it possible to have fractional zeros? Well, yeah, we just got 2 of them, yeah? So watch this. This is the last thing I'll show you today. If I had this, let's make it a cube. Yes, sure, okay. My possible rational roots. What are the factors of 8?
Plus or minus 1, 2, 4, 8.
And what are the factors of 6?
1, 3, 1, 2, 3.
Okay, so I need you to understand. The numbers at the end tells me what goes in the top. In fact, every problem we did before now had a 1 at the beginning, yes, didn't it? Every problem had a 1 at the beginning. And that's why I ended up with 1s on the bottom. They were just whole numbers. The minute I have a number out front that's not 1, it could have a 2 somewhere, it could have a 3 somewhere, it could have a 6 somewhere. So that would mean a 2 could be on the bottom, a 3 could be on the bottom, a 6 could be on the bottom, yes? This ain't good though. This ain't good. I wanted to see the list. So what I do is this. 1 divided by 1, 2 divided by 1. I make all the ratios I can. 2 divided by 1, 4 divided by 1, 8 divided by 1, 1 divided by 2. 2 divided by 2 is 1. I already have that. 2 divided by 3 I don't have. 2 divided by 6 is 1/3. Did I miss my 1s? I did. Why did I do that? 1, 1/2, 1/3, 1/6. Okay. 2, 1, 2/3, 2/6. Okay. 4, 2, 4/3. 4, 6 is 2/3. I already have it. Is everybody kind of with me? 8, 4, 8/3 I haven't written yet. 8, 6 is 4/3. I already have it. Oh my God, Jeff, what the ever-loving shit. So the minute I introduce the possibility of fractions, that damn list gets big, yes? So thankfully, tomorrow, one of the main things we'll work on is several ways to make the list smaller. So before I even start trying shit, I could just kind of, in fact, I could try something and it could tell me something that will make my list shrink, which is really nice. So we'll focus on that tomorrow. Because to me, that's the worst part about these, is having these giant lists. I'm gonna die, it's too bad. It's been a good life. All right, guys, I'll see you tomorrow. Get out of here.